Hi guys, this is Samuel from TechWithSam again with another YouTube video where we're diving into performance optimization in Flutter. So basically, when we talk about performance optimization, it deals with how perfect, how optimized your Flutter app is built. When we build an app, everything is not just about coding. Building the app. There's one thing to build the app. There's another thing to optimize the app for good user experience. When an app is built and all the screens feel junky, is not well fitting for some devices for different OS. Let's say, for example, on some Android phone, we have different Android phones out there, so the app might be lagging on some Android phone and etc., and also be consuming a lot of user memory and stuff like that. So that's where Flutter optimization comes in. So today we'll be diving into the optimization aspect, and to optimize the Flutter application performance, we need to focus on minimizing unnecessary widget rebuild using efficient rendering techniques and managing resources efficiently. So the key step involve leveraging built-in tools for profiling, optimizing UI code, and also efficient data handling. So in today's video, we'll be touching 4 key parts in performance optimization. But before that, just a quick pause. A few weeks ago, I launched a free newsletter on my website, TechWithSam. You can check it out. So if you head over to techwithsam.dev, on the newsletter part, you can sign up and join my newsletter where I share weekly tips on code efficiency, performance update, and also some new release in this world of AI, probably some new software that you can try out. Also, I give early access to my project repos, some of my courses that I'll be releasing soon, and also some of the things that I'm working on in the future. So make sure to check that. You can just drop a comment in the comment section below and I will reply with the link, or you can check the comment. You can check this video description to see the newsletter link here. All right, let's go back to the video. So the 4 points that we'll be looking at today are performance diagnosis, widget and UI optimization, resources and data management, app size and build optimization. So when we talk about performance diagnosis, so we'll be going into it one after the other so we can actually get the gist. So this is my code editor and a simulator. So this is where we'll be doing the practical aspect so we can actually get it. So when we talk about performance diagnosis now, I have another 3 points here. So performance diagnosis, one of the points here is you run your app in profile mode. So in Flutter we have 3 modes. When running the app, we have the debug mode, we have the profile mode, and we have the production mode, basically. So debug, as the name implies, basically developments when you are debugging the application. We have the profile and we have the production. So profile is the closest to production. It's exact feel when you are running the app on production mode. So always profile your app in profile mode on a physical device, as debug mode performance is not representative of the final release build. So to have a feel of what the production will look like, always run your app in profile mode. And to do that, just go to your terminal. You can set it in your VS Code or whichever ID you are using. So just run, as I have here already. So just run Flutter run hyphen profile on Android. Just run like that. On iOS, if you have to specify the device, then you can just put ID, then the device ID here. So basically, that's how to run your app in profile mode. So with this, you'll be able to test the app. Ensure you also run it on a physical device so you can actually have a feel of how the app will look like in production. So that's one of the points for performance diagnosis. So the second point I have here is Flutter DevTools. So by default, when you run your app, you have a Flutter DevTools. As you can see at the, I think this should be left, at the left part, left or right, so at this sidebar of my VS Code, you can see the Flutter debug tool inspector. So this is like our Flutter DevTools. And to even have more comprehensive inspector, if you run your app now, you see this connecting to VM service. This is like a localhost URL. So if you go to this URL, you will see you see a beta inspector site, so you can actually run through everything. So now if I open this, so I will just copy it. I've actually opened it on my on my browser already. So let me just minimize this, my presentation slide, so I can just go here. So to open it, if you copy everything like this, you can just copy everything. Once you copy it, make sure you change the, let me just open it again. Make sure you change this WS to HTTP. So HTTP like that, so you can just open it, and it's open the inspector. So I already have it open here, so I'll just use this as well. So here we have everything necessary for you to actually inspect how your Flutter app is behaving. We have the DevTool Flutter inspector to see the widget tree. As you can see, all the widget tree in my app. I can click one to see the widget property as well, just to go through everything. So we have performance. You can check the performance. You can see when there's a spike in your what's it called, in your Flutter build. So we have the CPU profile, memory, debugger, network, all the login, basically everything that has to do with what's it called, DevTools. So you can check through everything just to have a feel of the DevTools. So this one is to see to inspect how the app is performing in different using different tools, basically. So you can see the memory the app is consuming, also all the logs. Even if you're not seeing the logs in your debug console, you can see the logs inside Flutter DevTools inspector. So that's one of it. So the next point I have also is the third point, which is performance overlay. So performance overlay basically is the use of built-in performance overlay widget in Flutter, basically. So to use performance overlay, if you come to this material app, so inside your material app we have something called show performance overlay. So they just set it to true like that. So if I set it to true, you see the performance overlay on this our Flutter, basically. So this performance overlay is just to show the frame of how your app is performing, and also the size that is using, basically. So when you see like a red line, that means it's taking so much CPU from the device, basically. So that's the performance overlay. So you can enable that to actually, for it to indicate when the app is consuming a lot of frames and stuff like that. Another point we can as well still try out is to use DevTool to identify junk in scroll list, or even in a reward scenario. Now we can enable something to do that. We just start with assert like that. So assert, then the function file. So we'll return. Okay, let's just start with this. So let me close this as well. Sorry, this should be closed. All right. So now inside this our assert file, then we can call what's it called, debug print framework. With that, we'll be using the scheduler that package. So we can just call debug print begin frame banner. So let's just set it to true. Okay, we can no. All right. So this should not be string. It should be bool. So banner, we can also add begin, end, and build scope, basically. So let's just say end should be true as well. We can also add build scope, yeah, also to be true. So let's just set this theory. So with this theory now, we'll be able to enable DevTool in debug mode, basically. So that's the work of this theory. So if I refresh now, so let me just restart the app so you can see what I'm talking about. So as you can see now, the debug tool, we can see it right in our debug mode, how it's painting every widget in our screen, basically. So that's performance diagnosis. So this is it. We have the profile mode, so make sure to run the app in profile mode to actually test how it works in production live while you are still debugging. We also have the DevTool. You can make use of the DevTool resources that we have to check the performance and everything that relates to the app using the DevTool software that we have in Flutter. So here now you can do everything. It has a lot of functionality that you can test through. I can't really go through everything now, so I'm not take much time. So you can see it has auto reload, auto restart as well. You can as well enable some settings here and there. So that's basically the DevTool. So then the last thing, which is performance overlay, to check how the app is performing right on this screen now. So if you add a lot of other stuff to this app, you can see the performance overlay that will increase over time. So to enable that, just call the show performance overlay here and you are good to go. So that's that for performance diagnosis. So let me just comment out this so we can proceed to the next thing that we have. So the next thing that we have on my slide, which is widget and UI optimization. So when we talk about widget and UI optimization now, so most performance issues stem from inefficient UI code, as you can attest. I mean, reusing widgets here and there and all. So the first point I have is minimize widget rebuild. So how can we minimize widget rebuild? As we all know, Flutter is a widget tree, that is, you are using widgets in throughout the whole application. So basically, a widget is sitting on another widget, like just like a tree, from the root to the stem and to the fruit and stuff like that. So how not to rebuild a widget, just like how we have inside this our counter widgets now. For example, if I click on this plus sign that we are using set state, sorry, let me just collapse this so we can have more space here. It's because of the frame, that's why this one is still there. I think I just have to restart the app so we won't see the debug, but regardless, I'll just leave it. So as I was saying, minimize widget rebuild. So to minimize widget rebuild now, one of the key thing is use const constructor. So const, as the name implies, constant basically. So constant basically means this widget or this variable whatsoever is constant, it does not change even during runtime. So that's constant basically. So as we have this test widget here that has a variable that is being called, and the variable tends to change over time because we are changing the value. That's why you can't use constant here. For example, if I use constant, it will throw an error because invalid constant value. That's because the value is in future is supposed to change, because we are calling a value and we can actually reset the value to something else. So we can't set this to constant because it can change even in runtime. But for values that cannot change, for example, this test now, if I remove this constant, and I click on the plus sign that is using set state, it will rebuild the entire widget and also rebuild this particular what's it called, text widget. So if I enable this show, let me enable this show performance overlay again so you can see what I'm talking about. So for example, let me just auto restart, let's reload rather. So click on this, you see that it rebuilds the entire widget again with how the frame is going. But if I add constant here, this particular widget is not being rebuilt, so it only focuses on this particular test widget that does not have constant. Any widget that does not have constant, it's automatically rebuilding, especially when we are using set state. Now when we go to state management solution, then we can even minimize how states are being rebuilt. So now I can click on this plus sign. You can see as well it reduces the frame from the UI marks, and also how fast it actually rebuild the frame. So that's because some widgets are not being rebuilt because they are already set to constant. So the first point is use constant constructor for widgets that does not change, to allow Flutter to reuse them at compile time, reducing runtime overhead. So that's basically, so make sure to use constant. And one of the beautiful thing in Flutter is you can set a lint rule, like inside your analysis option, you can set a lint rule to always signal you when a widget should have constant, and probably you forgot. So you can set the lint rule to do that. I can't really remember the lint rule right now, but let me just check. Is it constant identifier names? Okay, is this it? Let me just confirm if this is what we want. No. Before the end of the video, if I get it, then I will add it to it. But basically, in your lint rule, you can set a rule so that it will actually notify you when there's the need to add constant to a widget and probably you forgot to add it. So that's basically it. So the next point I have it, refactor large build method into smaller dedicated stateless widgets or stateful widget classes to localize the scope of rebuild. So instead of having chunks of widget tree inside a particular widget, why not just break it into smaller widgets? For example, now, well, this widget is actually small, but if I want to have, let's say for example, I want to have another container, or let me just say I want to build list view builder. Okay, list view builder like that. Let me say context. Okay, let me just accept this and stuff. Okay, let me change this to single child scroll view. All right, so as you can see, we have added another widget. So for example, this is just the dummy data, but normally a list will be that we have like a comprehensive return widget. So for this list, instead of returning this list, I can just build a simple stateless widget so as to return this particular widget. So so I can just say list widgets like that. So let me just return what we have here. So return list style. So this index, I can just request for the index, which is int index, then which is required. So with this, we are breaking the widget tree. So by the time we are rebuilding this widget, it's not rebuilding this particular class again, because we have separated it. It's not under that widget tree. It's like a separate class on its own that is being called inside this particular widget tree. So that's the essence of like rebuilding refactoring large build method into smaller ones. So that's that. So the third point for minimize widgets rebuild basically is use state management solution. That cannot be overemphasized. So make sure to use state management solution. We have the popular ones. We have provider, we have Refactor, we have block. So with provider, with Refactor, with block, you can rebuild widget, a specific widget, without needing to disturb the whole widget tree. You can rebuild specific widgets rather, without even necessarily rebuilding the whole entire tree. That's the major essence of state management solution. So with consumer or selector, you ensure only the necessary part of the UI rebuilds when the state changes. So that is that. So the third point, or the fourth point I have for this minimize widgets rebuild, is use value listenable builder or animated builder for fine grained updates instead of calling set state on large widget. So instead of using set state on large widgets, basically we don't really have any large widgets here, so that's hence why we can still use, where's the set state? Okay, why we can still easily use set state here, and the app won't feel too laggy. But when you are building a large widget, make sure to use value listenable builder. With that, you can rebuild a particular widget without necessarily rebuilding the entire stuff from scratch again. So that's 4 points on this minimize widgets build. The first one being use constant always for any widgets that does not change. For any widget that don't change, to allow Flutter to reuse them. So basically, the next one is refactor large build method into smaller one, into dedicated like status widget or stateful widget classes as it occurs. The next one is use state management solutions. Your favorite, you can start with provider to Refactor or block, anyone. The fourth point, which is use value listenable builder or animated builder to fine grain update instead of calling set state on large widgets. So that's that on minimize widget. Then the next point I have here, which is optimize list and animation. So for long list, as you can see, these are our long lists where we have here. For long lists, use list value builder. Basically, some people, we also have list. For example, let me just say column like this. If I use column, then let's say children. So let's close this. I can use list.generate like this. So let me just say 12. Let me change this to, let's say, it text like that. All right, this is data. Okay, so instead of using this list generate, which will actually require a lot of data, we can make use of list video builder. So with this, we are creating a lazy load time. So a lazy load time basically means is taking its time before loading the before loading the widgets, basically. So it will consume the CPU. Every device is everywhere has a CPU, even our mobile devices, which they run with the RAM of the device. So with that, it will create a simple space. It's just like using them only when they become visible on the screen. So instead of just dumping everything, like you want to generate 1000 lists, instead of just building everything once on the screen, since 1000 lists cannot actually fit into one device screen, so while you are scrolling, when they are required to be visible on the screen, that is when they will be built. So that's the purpose of using list view builder. So list view builder, you can as well, we have silver list as well. So silver list is so silver list like this. So we have silver list builder, so you can use silver list builder as well. So sorry, silver list builder like that. Okay, we have shrink. So silver list, and we have list builder basically. So this is how it works basically. You can either use, but most Flutter developer use with list view builder. So that's that for the first one, which is optimized list and animation. Let me comment this out so we don't have too much list. So the next point is wrap complex or frequent animation widget into repaint boundary to isolate their repainting from the rest of the UI. So when you are dealing with animation, you know, animation basically is painting all the elements on the screen. And for example, if a user is using a let's say a low, probably a device that does not really have much power or much refresh rate, it will be hard for that device to actually paint all the elements on the screen at once, which will cause a lot of lag and a lot of downsides for that particular device. But to resolve that, we can wrap all complex animation widgets in repaint boundary. So this will actually isolate the repainting from the rest of the UI. So it will just pick that particular animation that you're trying to achieve and build it separately. I mean, isolate it. It's just like separating that particular animation from the rest of the UI. So while the animation is still building, the UI is working fine. So the animation does not disturb the UI, and the UI does not disturb the animation. That's the purpose of repaint boundary. So yeah, so this is it. So repaint boundary, so you can wrap your animation inside it basically. So that's that for optimized list and animation. Then the third point I have is avoid using opacity widgets directly for animation. So instead of using opacity, even the opacity has been depreciated in the current Flutter version. Like for example, if I call let me just choose an icon, let me just say icons dot star, okay, like that. Then we call color, so colors dot red. Then with opacity, as you can see, opacity has been flagged out. So if I let me just use it regardless, let me just say 0.2, close it. So as you can see, this with opacity has been depreciated. And also to avoid junky, is like instead of using opacity for animation, you can use fade transition instead of opacity, as it is more performance. As you can use fade transition instead, as it's more performant. So it works better than optimization. It works better than opacity. And for color, although this is different, for color you can use with values. So with value, then you can call alpha like that. So alpha works pretty much like opacity as well, to reduce the frame of this particular what's it called, color. So that's pretty much it. So in optimization, again, I mentioned use list view builder instead of loading the list at once on the UI. Also, I mentioned use repaint boundary to isolate repainting from, to isolate animation repainting the rest of the UI. And also I said avoid using opacity widget basically. So that's that for widget and UI optimization. So the next point I have now is resources and data management. So when we talk about resources and data management, actually this is kind of much. So resources and data management has to do with when we are working with internet basically. So we have image handling, we have asynchronous operation, we have memory management and network optimization. So when we talk about image handling, so the first thing is, if you are fetching image from an endpoint, or you are loading image from network, so instead of using image.network like this to fetch image from a particular URL, with this it will always fetch the image at every given instance. That is, every time the widget is being built, it will call this image. But we have a particular package which is let me just go there, pub.dev. We have cache network image. So cache network image. With this, it will save the state of that image without needing to rebuild it, or without needing to actually fetch the image. This is a good experience for not just the user experience, also for the user CPU as well. So with this, the user don't need to actually be loading all the image at every given instance. So that's the purpose of this cache network. So use cache network package for image from network to implement efficient caching and reduce network request. So the next point I have for image handling is compress image before bundling them with the app. So the next point I have for image handling is compress image before bundling them with the app and loading them at optimal resolution. So basically, in our Flutter app, we use assets. So when you are just bundling assets, image file. So instead of just bundling them directly to let's just leave it. We are not using it anyways. All right, so instead of just loading them directly into our application frame, we can load them at optimal, at the first instance of that particular screen, instead of loading them inside the UI. So we can load them at the first instance without needing to bundle them every time the widget is being built. So that's that for image handling. So the next point I have is asynchronous operation. So for asynchronous operation, basically just like what we did here inside this what is it called? Okay, I didn't later do it. So inside this asset, we can perform some asynchronous operation. So asynchronous operation simply means delaying function before it happens. So in asynchronous, we have feature, we have async and await. So async basically means asynchronous, and await is waiting for the value to be built. So now I can say feature.delay. So delay. So then we require to specify the duration. So the duration, let's say seconds. You can just say 1, then what we want to delay. So just give it like that. All right. So yes. Okay. So let me close this. Let me copy all this. Okay. Sorry. Yeah, I think I missed something. That should not be. It should not be circle bracket. It should be curly bracket, like that. Then we are good to go. So circle bracket and curly bracket. Then this, we have to close this as well. So we can import this our scheduler again. All right, so basically when we talk about asynchronous operation, so use async with feature builder and stream builder to perform network request and other input and output operation without blocking the main UI thread. So basically, the way I did this earlier, that we didn't use feature delay, now it will actually block the main UI thread without this particular delay. So this asynchronous basically is like, for example, now we can perform asynchronous here. So you can just say async, then wait for although this is not a feature function, we can just create another feature function now and say I wait for it to actually load, just like what we have here. So scheduler bind instance and end of frame, so like this. So this is actually performing like asynchronous operation. So the purpose of it is to actually perform our network request and other input and output operation without blocking the mainframe. So with the help of async and await, we also have async with start to async all. That's for some advanced stuff. So we have feature builder to load some network requests. Also we have stream builder to listen to some stream to build some network requests basically. So that's pretty much it. So the next point I have for asynchronous operation is for CPU intensive tasks, use heavy data processing. So you can make use of isolate via the compute function to run them on a separate thread. So we have isolate function. So I'm not diving into that, but if you check isolate stat, so you'll be able to like get another, you can So if you check isolate that, you'll be able to get the gist, because that's a little bit complex. That's like an advanced topic, so you can check it out. Just search dot isolate. So basically, so you with that's if you are running like heavy data processing, like you want to render some heavy data like image compressing, some other heavy data processing, basically, then you can make use of isolate to actually compute the function, so it can run on a separate thread. Yeah, so that's that. So that's pretty much on asynchronous operation. So the next thing now we have is memory management. So memory management is all the controllers. When you're building your app, you have controllers. Like, for example, we have animation controllers, we have text editing controller, stream subscription instance, and some other. So memory management is you actually disposing all this controller when you are done using it. So for example, now inside this my app, let me just create the text editing controller. So let me say text editing controller. Okay, let's say controller like this. So most people don't actually dispose their controller once they are done using it, which is a cause of memory leakage. That is, it will slow, which is actually memory leakage, which is very bad when it comes to development. So to dispose, just call the dispose function. So to do that, just call override. So override then void dispose, like that. Then the dispose function, then you are good to do. So you have super dispose. So make sure you dispose your controller, your animation controller, what else, stream subscription. So the other resources in dispose method of your stateful widget is to prevent memory leak, basically. So with this, it will prevent memory leak and other essential data. So it won't expose any data inside your controller to any attacker. So that's pretty much on memory management. So the next thing I have is network optimization. So implementing, just like we implemented this lists, where is it, this list builder now. Okay, sorry, I've closed it. Let me open it up. Just like how we implement this list builder, as you can see, the item count is 100. So instead of just showing the whole 100 item, when we are dealing with network optimization, when we are fetching data from internet, we can implement data pagination for large data sets to avoid fetching all data at once. When you are fetching data from the internet, you are just fetching everything at once and loading everything at once. First of all, it will delay the response time, because the data is fetching from the server is actually very large, which will delay the response time. Instead of taking 5 seconds, it might be taking 15 seconds, 20 seconds, and for users to be waiting for the data to actually load, which is a very bad user experience. We can actually paginate the data. So pagination basically is load the first, let's say 15 data, then once you just scroll, just like how we have on social media. If you have LinkedIn account, X, also known as Twitter, Instagram, and other social, even on YouTube, when you are scrolling, you can see that all the data is not just loading at once. As you are scrolling, viewing is loading the data as requested. So that's basically, so when you request for the data, that's when it will load it. It's not unnecessarily just load all the data as once. So that's one of the best way to actually like optimize network call. So the next thing now is to cache API response to reduce the number of network calls and improve perceived performance. So instead of calling API every given instance, you can actually cache it. We have different cache method. We have shared preference, which is the Flutter shared preference. We have ISA. So the shared preference, you can see that is developed by Flutter. Shared preference, we have Hive, although Hive is a community project now, so Hive community. So you can see Hive, this is Hive. We have ISA. We also have, you can see all this stuff, and non-SQL database where you can actually cache API response, so the user don't necessarily have to actually fetch the API every time, that everything have to be loading here and there before the user actually see data. Like for example, if you open your Twitter account now, it won't necessarily just load the data. There's some cached API response already on it, so it will just be on it. So once you scroll up or scroll down, it will automatically refresh at the background, so it will automatically show you for you to actually load some new data for you to see. So that's one of the best way to optimize your network request. So the last but not the least point that I have here, which is app size and build optimization. Although different app have different size, but generally you can reduce the size of the app. Instead of just loading everything, you can reduce app size, remove unused assets. When building app, you can add unnecessary assets to it. Probably you think, oh, it's part of the necessary stuff, but you find out that you are no more using it. Just remove unused assets also, and libraries as well. I mean, if you are using a lot of packages and some of the packages, dependencies are not necessary, just remove them as well. And probably you're using some font style that you are not using at the end, you can as well remove them. With this, you are reducing your app size. The next thing as well is you can run a command to generate small APK for different device architecture. So to do that now, just go to your terminal. Let me delete this. So you can just say Flutter. So Flutter build APK. So Flutter build, that's the normal command to build APK. Then we can add this extra layer function, which is split per AB. So split by ABI. So basically this one, we split the APK and generate smaller APK for different device architectures basically. So with this, you have a smaller size of the application, instead of having over 100 MB application that once you upload to iOS app store connect, it will be very light that users are even scared to even install the app for a very small app that does not really have a lot of functions like that. So that's for app size and build optimization. The next thing now I have is enable release mode. So always verify final performance using Flutter run -release or by building the app in release mode. So to finalize everything, when you're ready to launch your app, always verify everything by running the app in release mode. So basically, to run just like how we did for profile, you always run your app in release mode, and with that you have been able to successfully optimize your Flutter app. So as I mentioned, some of the key points I mentioned is performance diagnosis, widget and UI optimization, resources and data management, app size, and build optimization. So basically, with this, your app will be able to run swiftly. With this, your app will be able to run swiftly on any device or any OS without having to have a lot of junk for the user to have a good user experience. Let me know what you think in the comment section. If you have any other thought about this, let me see your comments in the comment section. And without further ado, I will see you in the next video. Bye for now.